So again, the title's Deck Ledger Flashing and Stair Solution. We'll be doing about 45 minutes on each. And like Marcy mentioned, if you got questions, particularly about the ledger flashing, be sure to jot them down so we can hit those at the end. A lot of the materials in here are copyrighted, some by the American Wood Council. I'll show some of their illustrations, as well as by the International Code Council from some of the code stuff. This is the AIA slide. I'm not going to read this, but you can refer back to it in the handouts if you want to know more about the education program that you're seeing. And this is the course description. You may have read that, but I won't read it again. We'll just dive right into it, as well as the learning objectives. You can go back and look at those in the handouts later if you haven't already reviewed those. First question, I'll turn it back over to Marcy.
As always, we like to know who we are speaking to, and we welcome everyone who's here. Okay, so we've got 52% engineers, 33% code officials, 10% architects, and 5% builder, manufacturer, or other. Again, we are delighted that all of you are here and hope that you find something of value.
So we back on my screen?
We sure are.
Okay, good. I'm looking, I can't see it. Okay, so the ledger flashing, they're just looking at the requirements that are in the code book, and there isn't a whole lot as far as the prescriptive measures. What we have is a couple of performance requirements. The first of which, since we're talking about decks, is in the deck section of the code, which is in chapter 5 towards the end of that chapter on floors. And the flashing portion is actually buried as a footnote to a table. And as we know, especially if you're code officials, a lot of contractors don't look at footnotes necessarily, so they may overlook this, but I try to point it out in my presentations. It's footnote A to table 507.913 parentheses 1, and it says ledgers shall be flashed in accordance with section 703.4 to prevent water from contacting the house band joist. So again, it doesn't give us a prescriptive measure on what we're supposed to do. It just says we gotta make sure that the water doesn't get into the house. And then if we go over to 703.4, it gives us a whole bunch more information. And this is in the wall covering chapter. So this would apply to a lot of things. I just want to highlight a couple of them. The first is we need to approve corrosion resistant flashing. And then it mentions self-adhered membranes, so we can use self-adhered membranes providing they comply with the AMA standard, and we can also use fluid applied flashings. But what I really want to highlight is something that's often overlooked later on down in the bottom of that code portion, and it says flashing shall extend to the surface of the exterior wall finish. And a lot of people think, if they flash things, they'll flash it back to the WRB, the water resistant barrier or weather resistant barrier. But they don't always think that they have to kick all the flashings out to the surface. And though it can be difficult with some types of siding, it is super important to keep the water out from behind the cladding, because the less we have to rely on the water resistant barrier to keep the walls dry, the better off we are. And then it goes on further down and it says where exterior porches, decks, or stairs attached to a wall or floor assembly of wood frame construction. So just pointing us to where the location would be that would apply in this case to decks. Other things in chapter 5 about flashing, it says that the flashing shall be corrosion resistant and a nominal thickness less than 19 thousandths of an inch, which is roughly 26 gauge if you're familiar with using gauges rather than thousandths of an inch. And then it also lets other building officials approve other non-metallic materials that are compatible and so on and so forth. What I really want to focus on here, because a lot of contractors use metal flashing, is the 19 thousandths of an inch thick. A lot of the flashings that we find in stock at local lumber yards don't meet the 19 thousandths of an inch or 26 gauge thickness. A lot of flashings, and I'll show some a little later on, end up only being 11 thousandths of an inch, which is just a little more than half of the thickness. You don't think, when you hear 19 thousandths versus 11 thousandths, you don't think, oh, that's not much of a difference. But when you think in terms of how thick they are relative to one another, that's a big difference. On the ledger flashing, I'm going to go through a sequence. Now, again, this is since the code only gives us a performance requirement, which kind of leads us to a directive that we have to keep the water out of the walls. It doesn't give us the methods for how to do that. So this is an approach that I use, and as well as a lot of contractors I've met over the years who work in northern climates, particularly snowy climates and wet climates. So it may not be applicable everywhere. If you're in the desert Southwest or in Death Valley, where you're only getting, 2 to 8 inches of rain a year, you could probably get away with a simple metal cap flashing. But in areas that receive a lot of rain, 40 to 60 inches or even 20 inches of rain a year, particularly if it comes down in heavy sheets at periods of time, we want to keep that water out. So I use a redundant, sort of a redundant flashing system, where I back up behind the ledger, as you can see in this illustration. Then there's a piece of self-adhere membrane that goes over the top of the ledger, and then a metal cap flashing or a plastic cap flashing that goes over the top of that. Now I'll go into the whole sequence of how I do this. This is derived from some presentations and articles that I've done at trade shows and in different magazines. So it's not, like I say, it's not a code requirement, it's just a practice that harkens back to good building principles. So first off, I cut out and lift up the water resistive barrier, in this case a house wrap, where I've actually cut the section out where the ledger would go, and then cut a head flap, and you can see a diagonal corner coming just above a chalk line there, which would essentially be the top of my ledger board. And I tack that up out of the way, sort of like the head flap when you're doing a window flashing installation. Now I want to back that wall sheathing up and the area behind the ledger with a piece of self-adhering and self-sealing membrane. These would be like the self-healing membranes that we use for underlayment for ice barrier on the roof, or they're also types of flashing tape. Not all of the self-adhering membranes are self-sealing as well, so I like to use the ones that are self-sealing. They come in both rubberized asphalt, in butyl, and now in some acrylic and copolymer adhesive compounds on the back with some of the more recent product introductions. Any of those would be suitable for the way I approach this. Now what I'm doing here in this picture is scoring the release sheet on the back side of the membrane. So the membrane size is 3 to 6 inches longer than what the ledger board would be. I don't like to work in long pieces, so I'm going to work in 3 to 5 foot long pieces, something that I can handle in my wingspan of my arms. I'll make it as high as, in height wise, it'll be 3 to 6 inches taller than the ledger board itself, or wider than the ledger board. And that's so I can get a little bit of the material above the top of the ledger board, and then a little bit of the material down below the bottom of the ledger board. Now what I'm doing here in scoring that release sheet, I'm scoring it about 2 inches up from the bottom edge using a straight edge. Easiest way to do that is with a brand new knife blade in a utility knife, and not putting any pressure on the knife, just letting the knife blade drag across the release sheet, whether it's a paper or plastic release sheet. Usually just the mass of the knife will push the blade through just that paper or plastic portion without scoring into the adhesive or into the cap sheet on the top of these membranes. And later on, you'll see why I've done that. It's mainly to be able to integrate the siding later on. So here I back folded it just to show how this works out. Once you score the release sheet, you can see you can peel it off in separate pieces, and that makes it easier to apply the sticky side to the wall exactly where I want it without it getting all out of control and sticking where we don't want it, especially on a hot sunny day. So I'll pull the release paper off the wider portion and then apply it to the wall about 1 inch to 2 inches above the top, where the top of the ledger board. So the top of the ledger board would be right about here, right about where that printing is on the sheet, and then I'm making sure it's high enough. And then you can see that lower portion where the release paper is still left on is just over the house wrap below the bottom of where the ledger would be. When I put this first piece on, I'm going to make sure the end of it will cover over the house wrap on the, in this case, the right side by 3 to 6 inches. And then because I'm only working in pieces that are 3 to 5 feet long, I'll need to overlap each additional piece by about 3 to 4 inches just to maintain a good coverage and bond over each successive piece. Then the ledger can get installed, and then the fasteners we'd use for those would be either the 1/2 inch through bolts or lag screws that the code calls for in there, the prescriptive measures, or some of the, in this case, I'm using some of the proprietary type ledger screws. This 3 to 6 inch measurement, I have the arrow off in the wrong spot. It should actually be over, just over the membrane here. So we want that membrane to extend over to the house wrap by 3 to 6 inches past the end of the ledger board. And that's to back up the butt end of, or the butt joint of this cladding that'll come in later, be it lap siding or be it any other type of cladding, stucco, stone, brick, or so on, later on. And then this bottom portion here, we've got 2 to 3 inches with at least the bottom 2 inches with that release paper still on there. Now I'm going to prep some more sheets, and these are going to be strips of the same self-adhering, self-sealing membrane that's going to go onto the wall sheathing and then over the top of the ledger board and then a little bit down on the face of the sheathing. So the overall height of this, I'm going to make it so that it's got a wall leg of 6 to 8 inches. That would be from where I'm making this score line here. I'm scoring the line at the point in the membrane that would meet that inside corner where the ledger meets the wall. So I'm going to leave an extra 2 to 3 inches that will be over the top of the ledger board and down a little bit of the face of the ledger. So overall, the size of this sheet would be somewhere between 8 inches and up to about 12 inches in size. So I'm going to start off by folding the release, or folding along the line where I've scored the release paper or the release sheet if it's a plastic sheet, and I'll place that piece of membrane up against the wall over the ledger, and then I'll peel off the release paper on the ledger portion, that 2 to 3 inch lower portion. And that way I can fold it down onto the top of the ledger and over onto the face of the ledger without it bonding to the wall. If we tried to bond it to the wall and had removed all of the release paper in one sheet, both the portion over the ledger down the front and on the wall, we'd end up having a problem getting it nice and tight onto that inside corner where we could get some bridging. And if we ever get bridging with flashing membranes, especially if we're going to put a metal cap flashing over the top that has a crisp bent 90-degree corner in there, there's a chance that we might rupture that bridged portion of the membrane, because these type that I'm using here are not very flexible, not like the flexible flashing tape to go around corners. I'll show you some of that later and some uses for that. So once I've got that down onto the top, then I'll peel off the release paper on the backing sheet and then fold that up against the wall. Again, working in these pieces that are 3 to 5 feet long, making sure, again, to make sure it's tight on the inside corner. Over at the very end, I've extended that past 3 to 6 inches past the end of the ledger so that it's capping over the sheet that's beneath it that was behind the ledger board, and then just using a sharp knife to make a relief cut from the inside corner. That way it can fold one portion against the wall, and the little bit of leftover after a diagonal cut can wrap around the end of the ledger board. Then I can put on successive sheets, again putting 3 to 4 inches of overlap between those successive sheets, and work my way all the way down the ledger board. A good contractor could probably do 8-foot long sheets if you had 2 people, but I found it's just not worth the risk of getting the sticky backside stuck where I don't want it. So I just work in those smaller pieces. Now it's time to put on a metal or a otherwise approved flashing over the top. Again, minimum thickness on that's 19 thousandths of an inch. And the way the code's written, it says or approved flashing. So that approved is there a trigger that the building official is going to be the one that's going to be approving that. And hopefully the contractor has checked with the building official before they go ahead and put something down that a local official may not be too fond of seeing used, something that's thin or something that's a material that wouldn't be appropriate. So that an approved does lead back to the decision by the local official. So now we'll turn it to Marcy for the first question.
Sure. So let's see. According to the 2018 IRC section R703.4, flashing shall extend to the surface of the water resistive barrier, counter flashing, exterior wall finish, deck ledger surface, or none of the above. And 61% say exterior wall finish, 17% deck ledger surface, 10% water resistive barrier, and just a couple for the others. So we're a little bit across the board here. So Mike, why don't you kind of clarify for us?
Okay, so the right answer, it's not highlighting. The right answer is the, I got to think about this. No, it's the exterior wall finish, because that's the way the code is written. A lot of people think it would be the deck ledger surface, which is what I was doing in those slides when I put on all the flashing. But really, eventually that flashing system has to kick out onto the surface of the cladding. And we'll see that when we get a little further on with this ledger flashing system. The weather resistant barrier, there are some parts of the code, like for instance, with the window flashing requirements, it says in there that we can we have to extend the flashing either to the cladding surface or to the weather resistant barrier. But with this section, 703.4, it does say we have to go to the surface of the cladding. Now the size of the wall leg of that metal flashing that I'm putting on, I like to see them greater than 5 inches. Actually, when I do them, I usually go anywhere from 7 to 8 inches tall. That's because of the requirement for the siding, which is going to get installed later. Most of the locally available metal cap flashings that are intended for ledges around me at local lumber yards are far shorter than the 5 inches that I look for as a minimum. The one on the left here shows 1.5 inch wall leg. And in fact, this cap flashing, which has 1.5 inch top leg over the top, that will go over the top of the ledger, you'll notice how thin it is. This mill finish aluminum, I find that is often does not even meet the code minimum thickness of the 19 thousandths of an inch. This is an example of that 11 thousandths of an inch flashing. So that's a flashing that would not be appropriate to use for ledgers. The one on the right is a galvanized steel that's been coated with paint on it, and it only has a 4-inch wall leg. It's not that these are not code compliant, it's just that we need a counter flashing to go over the top if we're going to use them. So just keep that in mind, especially if you're a designer. You're going to want to spec out a counter flashing, which is going to extend the height of these wall legs up appropriately high enough to meet the requirement for how high the flashing has to be above, or the exposure, how high the flashing would have to be to allow for a positive overlap or a mechanical overlap with the cladding above, allowing for the minimum exposure between the top of the deck surface and the bottom side of the siding. So each different type of siding has a clearance requirement over the tops of porches, decks, and patios. And that's what this illustration is showing here. Now we have to remember that we're going to be putting decking on top of those joists, so we have to account for that. We have to account for the space that's required, and then have enough overlap, essentially the siding becoming our counter flashing, unless we use a separate counter flashing over the top leg of that flashing. So here are just some examples of different types of siding that and the exposure requirement that's required by either industry associations or by siding manufacturers. Vinyl siding, most of the manufacturers, as well as the Vinyl Siding Institute, require a minimum of 3/4 of an inch above a deck surface to the J channel or the starter strip where the first course of vinyl siding would be locked into. Often I see those J channels drop right on top of that decking, and that's not in accordance with the manufacturers or the industry association. And in fact, if you look deeper into the code regarding many siding types, and specifically about vinyl siding, what it says in the code about vinyl siding is that to comply with the code, we as installers have to follow the manufacturer's installation instructions. So essentially the manufacturer's instructions are enforceable by the local building official. They are, by reference, they are building code. Cedar lap siding, like cedar clapboard, the Western Red Cedar Association, WRCLA, requires a minimum of 2 inches above the top of the deck to the bottom of that clapboard that's over, or any other type of cedar siding that's over the top of that. So that's a big distance. Cedar shingles, which are governed by the Cedar Shingle and Shake Bureau, they only call for 1/2 of an inch, and they're about the shortest of any of the exposures. Fiber cement siding is going to depend on the manufacturer. Each one has a different height, and those range from 1 inch at the shortest and up to 2 inches by the most tallest. And then there are any number of composite siding and engineered types of wood siding, and almost all of those, when I've looked at the instructions, all call for a minimum of 1 inch, and that would be manufacturer specific. So we do need a space there, and that's why we need to have that wall leg of that metal flashing, if we're putting it on there, as well as the self-adhered membrane, if we're using that to cap over the top of the joist, need to have that tall enough so that we can have that exposure and the decking and have enough overlap of the cladding over that, so that we don't have a problem where wind-driven rain drives the water up and gets back to the wall sheathing, and then where it can leak into the house. There is another flashing detail. Well, it's sort of a flashing detail. This illustration is from the DCA 6, the American Wood Council's DCA 6 document. And it's the illustration showing where the fasteners should be placed through the rim board of the house, or the band board of the house, when you attach a ledger. But it also indicates that I've highlighted here in red, a flashing. And it shows the flashing going straight out across the top of the joist, and it doesn't show it going down, as I showed in my detail, over the front face of the ledger. Like I say, there is no code requirement in how we design these flashings. We just have to have a flashing system to get the water away. But a lot of people, a lot of contractors do use this type of a flashing system. And I just want to point out a couple of concerns about this that installers should pay attention to. Again, it's not enforceable by code, but it is something that installers want to be cognizant of when they're bending up their flashing. The flashing here in the DCA 6 shows that flashing extending out past the first joint between the first and second deck board that are laid up against the building. This can be a problem right here when you've got the gapped boards with that flashing extending under it, because we're going to get debris that'll collect in there. And it can also collect between the deck board and the wall where the flashing is where the wall leg of the flashing is. So those 2 points are places where we get debris collecting, and we know from just examples of following what homeowners do or actually don't do, they're not really good at maintaining their houses in general. So debris that collects in there isn't getting washed out on a regular basis. So you can get mold and actually moss growing and plants growing in there, which, not that it's going to cause problems with some of the modern deck boards that are pretty much rot resistant plastic and plastic composites, but with wood types of decking can exacerbate some potential for decay in there. So we don't want to have that happen. Another way, or here's just a mock-up that I made showing just what I'm talking about with that flashing going out over the top of the joist and where those debris collection spots would be. Ideally, the flashing could be stopped at the outer edge of that first deck board so that that joint that's between the first and second deck boards can have flow through, so that any debris that gets in there will wash through. The DCA 6 will probably be changed a little bit when they update it for the 2018 IRC, and they might shorten up that ledger flashing extension just so it doesn't show it covering up that gap. But we still have the problem back here against the wall, and I'll show you a solution for that. Before I do that, I want to mention that one of the advantages of having this type of a flashing that extends a long leg that goes over the joist is that it provides a rain shield, a water shield over the top of the deck joists. And that can benefit the joint of the joist where the hangers are, so that the hangers aren't being exposed to as much rainfall. And I learned this in my own experience just recently, in the benefit of having those hangers covered, where I took apart a deck I built about 11 or 12 years ago, and it wasn't on the ledger, it was actually on a rim joist, where I used the rim joist as a rim beam, but I had put a cap flashing over the top of the rim beam, and it extended about 1 inch over the hanger. And the hangers themselves looked as good as new. So just getting the water to shed over the hangers reduces the potential for corrosion there. So here's a solution if contractors do want to use the top leg that extends out over the joist, is to kick up the deck boards by putting some spacers there, some tapered spacers. Here I'm just using some red cedar shingles, but this could also be done with some taper ripped pieces of pressure treated wood or other rot resisted wood. And by putting those pieces over the joists, you can see in the photo on the right, I'm creating a space there so that water and debris can flow through. The only place it could get trapped is the small area where those spacers are positioned. And it's also important to keep that deck board away from the wall flashing by about 1/2 inch. And that way the water can flow right through. One of the things that I'll do very frequently when I do my own decks is, because I like to have the design a cap flashing that has a drop leg at the ledger rather than extending over the joists, I will lower my ledger board by about 1/2 inch lower than the height of the deck that I am intending to build. So I snap my chalk line where I'm going to have the height of the deck, then I snap a second chalk line for the height of the ledger, 1/2 inch lower. Then I do my flashing. You can see here how that metal cap flashing that I've installed is sloped on the top, and that way it's going to promote drainage away and down from the wall itself. Then that first deck board is held back about 1/2 inch or 3/4 inch off the wall. That way I can get water flowing through and behind the deck board over the top of that sloped flashing, and then down off the face of the ledger board. I've already checked with the 2 major hardware manufacturers that make joist hangers, and you'll know if any of you have installed these, you've noticed that the joist hangers that are sized for each of your common joist dimensions, your 2x6, 8, 10, and 12, they're always about an inch shorter than the actual dimensional height of the joists. So because of that, I can lower that ledger and not have the top fastener impinge too close on the top of the ledger board. And I've checked with the manufacturers on what the minimum edge distance is to that top fastener, and most of them have said 3/8 of an inch. So as long as I've got a 1/2 inch of meat there left to that top fastener, I'm not going to have any load reductions on those hangers. Then the final step in this flashing assembly is to drop down the weather resistive barrier or the house wrap over the top of that, essentially acting as a counter flashing. Now, in the event that the wall is sheathed with one of the weather resistive barriers that are integrated with the wall sheathing, and there are about 5 on the market right now, those, because they have the weather resistive barrier bonded to the sheathing, we don't need a separate sheet, so you wouldn't be able to do this. But what I do recommend is using what's called a stripping sheet, which is just taking their flashing tape, which they flash over the joints in the sheathing with to make it an integrated weather resistive barrier. You can run one strip over the top of that metal flashing, or use a compatible liquid applied or fluid applied flashing to bridge that joint to the metal flashing. And that way you're getting that counter flashing effect in addition to the flashing, in addition to the siding going on over the top of all of this. Then at the end, just like on a window or door head, we're going to tape that flashing or use a piece of flashing tape or tape to tape that cut that we made in the house wrap that goes over the top. And now we're going to look down at the bottom. And this is where I've left that release paper on the bottom of the sheet that was applied to the wall before the house wrap, before the flashing tape got installed to the wall. The release sheet's on that bottom 2 or 3 inches. So if this was a deck where it's at grade level, where below the bottom of the ledger is just going to be a foundation, then I would just bond this sheet down to the remaining sheathing down to the foundation, and then put a trim strip on over that. But let's look at it in the case where we've got a situation where there's going to be cladding below that. Now, this could be at a knee wall of a that's on top of a foundation, or we could be building a deck that's on the second floor of a building, so that we have cladding down below that. What I do is bring that cladding up, particularly if it's a lap or a shingle style cladding or even vinyl siding, bring that up so that the last course or the next to the last course of siding tucks up underneath the ledger board and underneath that piece of self-adhered membrane, so that I can then pull that release paper off and bond it down to the face of the cladding. This harkens back to what I mentioned earlier with that code section 703.4 flashing, where we want to have the flashing extend to the surface of the exterior wall finish. So if we looking at this, we've got two places where we've got that membrane that's behind our ledger board acting as a flashing, so that we're flashing over the top of the ledger and over the top of the cladding. And we also have the flashing capped out over the top of the ledger board. So we're making sure we're getting to the exterior of our wall finish. Then before I bond that strip down over the cladding, I'll take and trim it off where either the last piece of cladding underneath this ledger board would go, or a trim piece would go. And that's what I'll be installing here, just a little 1x piece of trim that I've trimmed off the, or cut off the bottom of that flashing tape, so that it's about 1/4 of an inch above where the bottom of this trim strip would go. Then I can apply that trim strip over the flashing tape, Some people get concerned when you put that trim strip on or the last piece of cladding on over that flashing tape that you're going to be trapping potentially some water in there. But one way to avoid that is by taking some either little tiny wood strips, maybe toothpick sized or thickness, a 1/16 of an inch or an 1/8 of an inch thick, and you just place those maybe at 8 inches or 12 inches apart over the top of the flashing tape before the trim strip goes on. And that'll just leave a weep space back there so that any water that either gets behind the flashing, got behind the ledger and gets cast out onto the surface of the flashing tape will weep out behind, or water that may dribble down over the face of the ledger board and then creeps back under the ledger board to the wall surface where that flashing tape is applied, then it will then weep out over the top, or actually behind the trim strip. Then you'll notice we've also got that extension piece behind the, or past the end of the ledger board. That's going to be important because we're going to have the cladding butt up to the end of the ledger board. And just like a slip sheet that a lot of contractors will install at all of the butt joints of lap siding, that extra extension of that self-adhered membrane is going to act like a slip sheet so that in the event that any water gets through that butt joint, it will be cast out onto the top of the siding here rather than weeping behind the siding on just the water resistant barrier. Some contractors will, in addition to all of these measures to keep the ledger nice and water resistant, will also add a kerf, a saw kerf, about a 1/2 inch back to the bottom of the ledger board. And that's a good measure, like the old saw kerfs that were installed on the old wood sills of windows and doors from 50, 60, 70 years ago. That way any water that kind of rolls around the bottom edge of the ledger board would bump into that saw kerf, wouldn't be able to bridge it, and then would end up dripping off. So this is what it looks like in all its full finish. And once the siding gets clad in on the end and then over the top, we've got a fully weatherproof detail. I'm going to turn it over to Marcy for our next poll question.
Sure. So which of the following types of siding may require a 2-inch airspace above a deck? Excuse me. Is that red cedar shingles, some fiber cement brands, Western red cedar lap siding, vinyl siding, or answers B or C? It maybe should be B or C, or B and C. Okay, so 61% say answers B and C, or B or C, and then 16% some fiber cement brands, 12% Western cedar laps, red cedar lap siding, and just a few on the others. So let's have Mike come back and let us know about these siding.
Yeah, so the right answer is E, which is answers B and C, because Western Red Cedar Association calls for at least 2 inches of an airspace, and then some of the fiber cement sidings require a 2-inch airspace. And then the others are a bit less than that. The vinyl siding is 3/4 of an inch, and cedar shingles only require 1/2 of an inch. Now, there's nothing to say that we can't do taller air spaces, and taller is better. It's just that a lot of contractors and homeowners don't like to see the flashing there. But by choosing a color matched flashing that would match the color of the house or the color of the decking, it de-accentuates that difference. So another alternative to flashing is just to skip the flashing altogether. And we can do that in the code table for the ledger fastener spacing using 1/2 inch through bolts or 1/2 inch lag screws. There is an option for 1/2 inch through bolts with a 1/2 inch spacer. And a couple ways of doing that. You can use a 1/2 inch stack of galvanized washers or stainless washers, or there are some proprietary products now on the market that you can that are made for creating that 1/2 inch space. The red line that I've put on this slide illustrates the portion where we're going to need some sort of a wall finish. This could be a piece of aluminum or galvanized metal flashing, or it could be a piece of plastic that's intended for cladding, like a PVC trim coil stock, but needs something back there. It could even be some of the self-adhered membranes that are qualified for UV exposure. So as long as we have something back there that's going to be blocking the water, not just our WRB, and that way we can leave that half-inch space and just let the water flow through, and we don't even have any problems where if the event that there's any damage to the flashing where water can leak in. So it's just a way to avoid that. And then there are other proprietary products that are made for spacing the ledger board off of the wall. A couple of these, like the one on the left, is designed to space the ledger off the wall primarily for installing brick and stone veneer on the walls, but it can also be used for cases where you just want an extra wide airspace. The one on the right, it doesn't have quite enough space to work for brick or stone, but it's enough to leave after the cladding, which could be vinyl or shingles in the case like you see here, any type of lap siding or stucco, or some of the adhered stone type of siding, the synthetic stones, which are only about 1 3/4 inches, maybe 2 inches thick. This style here would work and create a space behind the back of the ledger to the cladding. These two products have ICC evaluation service reports. There's a couple of the products on the market that have, one does have a ICC evaluation service report, and one or two of the others don't, but they do have engineering letters for their fastening schedule. So those are options. Oh, and one thing to note about those, just want to go back one slide. One thing to note about these standoff products is that they're really handy when contractors are installing exterior insulation on the walls over the exterior sheathing. If we install exterior sheathing on the wall, it could be 1 inch thick, it could be 2 inches thick, or maybe even more. And there are problems with installing a ledger over those cladding systems. The code doesn't have any prescriptive measures. One of the structural proprietary screw manufacturers does have a engineering report, so that we can install the ledgers over up to 1.5 inches thick foam using their screws. Or these standoff products work great, and that's where I use them, is when a lot of the houses I build, I put 2 inches of exterior foam or exterior stone wool, rock wool products over the top, and that way I can create a space behind it, run the cladding over the wall, and still have a ledger on there without having a lot of flashing difficulty around the ledger when you have those foam the insulating exterior insulations on the wall. So I want to go over now and talk about cantilever joists. Though they're not real popular, they can be real problems for flashing because just butting cladding up to them and putting a bead of sealant around isn't a long-term flashing system that we can rely on. So first off, I'll start out with some self-adhered membrane of the flexible flashing type. These are usually the window flashing tapes that are flexible for doing outside corners and inside corners. I start out with pieces that are about 1 foot long and then about 3 to 5 inches wide, and then I score the release sheet right down the middle, and you can see that's what I'm doing here. I'm just back folding it face on face so that you can see that the back release, or that the release sheet on the back side has been scored. And then I take that strip, and starting at the bottom of the joist, I'll pull off the release paper off one side and then wrap that around the bottom of the joist and up onto the side of the joist, bonding that exposed portion of the adhering layer onto the joist, pressing that on really good. And once that's bonded, then I can remove the outer strip and then that can get folded down onto the surface of the WRB, and that way we get essentially flexible flashing tape saddle flashing. You know, we could solder these up out of some copper or lead coated copper, or we could even bend them up out of some malleable lead, but doing it with flexible flashing tapes today makes it much easier. Then I'm going to use a second piece that I've already prepared in the same way, scoring the release sheet, and that'll go over the top of the joist, and I'll cut a little head flap in the top of the joist, above the top of the joist in the weather-resistant barrier, much like a window head flashing preparation, and then expose the release sheet on that self-adhered membrane, put it down over the joist that's cantilevering out, bond that down to the sides, and then once that's bonded, I'll fold the other portion up onto the wall, and then eventually pull the head flashing down over the top, and then finally put some pieces of flashing tape over the one pinpoint where we've got a little notch in the WRB where the flashing tape wraps under it, and just sealing that off. Some of these flashing tapes can be left exposed to daylight, but this particular product can't. So I'm a little bit concerned, even though I've got the deck boards on top, that'll be somewhat shielding this from sunlight. I'd rather not have a problem where it deteriorates over time. So to prevent the sunlight from getting to it and to kind of hide it and give me a nice trim looking detail when I butt my siding and notch my siding around those cantilever joists, I'll just take a piece of aluminum coil stock that's colored to match the siding color and wrap one strip around there, and that finishes it off. So that's all I wanted to talk about for ledger flashing. I want to move now and spend the last 40 minutes talking about deck stairs. So if you do have any questions about flashing, we can pick those up in about 40 minutes from now. For the deck stairs, I'm going to rely on two things. One, the deck codes and in the IRC, and two, on the DCA 6 document. So I'm going to refer back to 2018 IRC, and pretty much there's nothing in that portion in Chapter 5 in the Section 507 on exterior decks. There's nothing in there specifically about deck stair details. So we're going to have to actually look over to Chapter 3, where there's a whole bunch on stair geometry, configuration, and so on. That's going to be the same and what we would apply for decks as far as the geometry goes. Here's some pages from the DCA 6 from the American Wood Council. You can look through those later as far as basic code compliant geometry. I won't get too deep into this. I want to focus more on the attachment of the stairs, but this would include the height of the maximum riser height between stair treads, the minimum tread depth, as well as the minimum space, or actually I should say the maximum space we can have in an open riser situation between the bottom of one tread and the top of another. It pretty much parallels the code requirement and limitation for guard systems. Once you're 30 inches off the grade or more, that you can't allow the passage of a 4-inch sphere. Then there's a couple of other pages in DCA 6 that talk about maximum spans for stringers, depending on whether they're a cut stringer or whether they're solid stringers, and then the guard configuration for stairs and guards along stairs, and then that gets into handrails and other things. Those you can just read right out of DCA 6 or out of Chapter 3 in the code book. They're pretty much the same there. I want to look at how we attach the top of those stringers to the deck frame, the footings that we need to have at the bottom of stringers, and then some contractor-friendly details for securing the guardrail post at the bottom of the stairway, and then a couple of other things about footings and landings on stairs. These first couple of pictures are going to just be some photographs that I've taken or some friends of mine have taken, or from some magazines that I'm associated with, where we look at where these are illustrations of what contractors have used their ingenuity, because there is no or are no prescriptive designs for attaching the top of stair stringers to decks. They've cobbled together any number of different manner of blocking and framing arrangements. And you'll notice this, caution symbol up here. These are not code approved. They're really not ways that we should be doing this detail, because you can't rely on the way these blocks are attached. So definitely this one, where you see some just nails from the back of an end joist into the stringers. We can't use any nails, toenails or otherwise, that are subject to withdrawal, and just a hand-driven nail into the butt end or the back end of a stair stringer is not adequate to support that, and it actually is explicitly excluded in the code as not being something we can do. The same with these toenails here. They're subject to withdrawal, and you can see how that evidences itself when these stairs started pulling away from the frame of the deck just a little bit, and now all of a sudden those toenails no longer are doing anything, and we're gonna lose that set of stairs in a not too short time period in the future. Another problem with the way a lot of contractors install their stringers, because they'll just butt them up to the deck frame itself, we don't have full support on the back side of the stringer by some part of the deck frame. And because of that, particularly in the case where the stringers are cut stringers, you know that these triangles that are cut out between the tread of the tread cut and the riser cut, those are prone to cracking along the grain line, and that's only going to leave a very small portion of the stringer left, and we can actually propagate cracks right at the area where the back of the stringer is indeed touching the deck frame, but the lower portion being unsupported. So these crack stringers that you see there, and that would certainly happen here if we got a crack propagating from there, are going to leave us with very little support back onto the deck frame. Again, some more of that lack of support for that heel of that vertical cut on the back of the stringer. Some contractors get ingenious. They think they're going to support the back of that stringer cut where it's below the bottom of the deck frame by adding a 2x block on there, but it's really only going to help them hold those stringers together. It's not going to provide any vertical or load support. So not something we want to do. And another one where they've done a fine job of notching around the post, they've notched around the rim beam, and they've notched around the bottom of that, doubled up rim joist. That's a cantilever, but again, it's not really supporting that portion of the deck frame or the deck stair stringers, and you can already see a crack propagating from there, and it's only a matter of time before we have problems. All of the illustrations you see here of tables and charts in the DCA 6 document, as well as you find comparable tables in the code, all are based on the load capacities for the deck itself. So this part of, I'm just going to read this little bit of from chapter 3 in the 2018 IRC, 311.5. This addresses landing, deck balconies, stair construction, and attachment. Exterior landings, decks, balconies, stairs, and similar facilities shall be positively anchored to the primary structure to resist both vertical and lateral forces, or shall be designed to be self-supporting. So I just underlined exterior and stairs just to focus our attention that we are talking about exterior stairs here. So these exterior stairs have to be positively anchored to the primary structure. A lot of people think the primary structure is the dwelling or the house, but in this case, since we're talking about putting these stairs up to the deck frame, the primary structure there is going to be the deck frame. So it has to be positively anchored to that deck frame, adequate enough to resist those vertical and lateral forces, or we'll have to make it self-supporting. Now I've got these tables down here to point out in this next slide that all of DCA 6 tables for our deck beam spans, our ledger fastener spacings, our maximum joist spans, and our maximum overhang spans for cantilever joist over a beam for a deck, as well as our footing sizes, are all based on a live load of 40 pounds per square foot and a dead load of 10 pounds per square foot. So for a total load of 50 pounds per square foot. It does not include any extra loads being applied to any of these framing members or the footings. So let's look at the detail that DCA 6 shows for connecting stair stringers to the deck frame. What it shows here is an outside joist that would be the end joist on a deck, like in this photograph to the left, or the rim joist that's closing off the end of joists that are maybe cantilevering over a beam. Then it shows a stair stringer coming up and then a stair stringer connector, manufactured piece of hardware that's connected to the, in this case, the end joist or the outside joist. But the code does not, and DCA 6 does not have any prescriptive measures for making sure that that end joist or the rim joist is adequately fastened or designed to handle the load, which would be half of the tributary load, half of the length of that set of deck stairs, which have the same live and dead load requirements in the code. That would be the 50 pound per square foot when you add the dead and the live load together for whatever lengths of the stringers. So if you look at these set of stairs in the photograph on the left, I mean, first off, they're probably overspanned for being cut stringers. If you look at the DCA 6 limitation on that, it would be about 6 feet. We can't go what looks like here, maybe 10 feet of a span. But more than that, even if it was only a 6-foot span, we're loading this single end joist here with that tributary load that would be applied to that. Now that joist is probably only sized to meet the load requirement for the 40 pound live and the 10 pound dead load above that. For the deck load, it's not sized to handle that extra tributary load. Now here is a case where we've got the rim joist on a cantilevered portion of a deck. Now let's say that this cantilever portion was figured out based on the DCA 6 table, which gives us limitations on a cantilever portion of L divided by 4, which would be the back span divided by 4, or the maximum cantilever that's listed on a table in the DCA 6. So if we've maxed out our cantilever to our rim joist, can we apply a set of stairs coming down, say another 4 or 5 feet down from there? Probably not, because we're already at our maximum load limit prescriptively. So we're going to need to have an engineer or an architect design or figure out what the load capacity would be for that cantilever, and if indeed we could apply a set of stairs. And then the rim joist itself, we have to be concerned about how that's attached to those cantilever joists. A lot of time contractors are only going to apply or use some 16D galvanized nails to hold that rim board on. Are those nails going to be adequate if we attach attach the stairs to that rim board? Is that going to be adequate enough to support those stairs? Probably not. So we're going to be concerned about that. In this next photograph, I can talk about a couple of the other things. So I already mentioned, is the joist itself, that end joist, if it's a single joist, is that adequate to support this set of stairs being applied to it? Now, maybe we could double up that joist. That might meet the requirement, but then it begs to, or leads to the question, is the beam that that joist is resting on, and then by load path, is the footing that's supporting that beam, are both of those sized adequately to handle that extra load that's on that joist, or maybe a double joist there, to handle the tributary load that's imposed on it by the deck stairs. If we're using those prescriptive tables from DCA 6 of the code book, then those the footing, the beam, and the end joist there are not going to be sized adequately. And then finally, the ledger board itself. The code table and the DCA 6 table for our ledger attachment, for all of, whether we're using 1/2-inch lag screws, 1/2-inch through bolts, or if we're going with any of the proprietary fasteners, the screws, the ledger type screws that manufacturers have, all of their tables as well are only for uniform loading of the deck joist on that ledger board. They do not include any concentrated or beam or girder loads, which essentially this end joist would be, because it's carrying extra load from the deck stairs. So we really wouldn't be able to do that without an engineer or an architect to calculate what that load would be to be able to install those deck stairs. So what's the other option if we're a contractor and we don't have an architect or an engineer involved in the design of the deck, which is probably a good portion of all decks that get built? Well, in that code section 311.5, remember I read out the whole portion earlier, and the last part of that said, or shall be designed to be self-supporting. Now, can I, as a contractor, design a framing system to support the deck stairs to be self-supporting? Let me walk you through the system that I use, and I think I can do that without going to an engineer and architect to design it. First off, I'm going to need some footings, because I'm going to have to independently support those stairs. So I put footings in, and those footings are going to go down to my frost line if my deck frame is connected by virtue of a ledger to the wall of the house. Or if this deck is self-supporting and not attached to the house, then in chapter 4, there's a section on footings in a exception for decks, where the footings only have to go, regardless of the depth of the frost, only have to go 12 inches below grade or to suitable soil. So if this was not a deck attached to a house, these footings may only be 12 inches below grade. But in this case, where I'm attaching to a house, because my frost line in Rhode Island where I work is 40 inches, I've got that footing going down 40 inches below grade. And then I'm going to use posts that are going to extend up to the rim board of that cantilever, and then I'll go through the rest of the assembly. But first I want to point out that most contractors are already going to be installing some guardrail posts to the deck frame for the guardrails that are going along the side of the stairs and then along the perimeter of the deck, if that deck is 30 inches or more above grade around the deck. So if they're already installing posts, all I'm doing here with this assembly is, instead of just terminating the post at the bottom of the deck frame, I'm extending that post down to those 2 new footings that I've installed. And that way I've continued the load path down. Not only does it reinforce the post so I know it's good and stable, but it's also given me a base on which I can attach the stair stringer assembly, or the stairway itself, to a self-supporting system. Now I'm going to put a headboard on. You could call this a header, you call it a headboard, you can call it a sub rim joist, you could call it whatever you like. In most cases, I'm just using a single because the load that's actually going to be on that is pretty small. and because it's only the top of the stairway. Now I can attach this as I'm showing here with some of the structural screws. I could use lag screws, I could use through bolts. That would probably be adequate enough to support the stairway, that at least in this case where I'm only going up about 4 feet with my stair stringers would probably be enough. And in this case, I calculated using these structural screws that indeed those 4 structural screws would be enough. But I'm actually going to do a little bit more than that after we take a poll question that Marcy.
Sure thing. So let me launch this. What is the total load that beam spans, ledger fastener spacing, maximum joist spans, and footing size tables are based on? Are laminations of 5/8 inch to 2 inch thick, laminations of sawn lumber or SCL, lamination?
You're looking at, I'm not looking at the same thing. Somebody.
Yeah.
Marcy, this is Gloria. I think we've got wrong answers in the poll there.
I think we do too. So let's just skip this. Sorry, guys.
All right.
My bad. I put the wrong answers in.
So let's go to my slide, and then because I think they'll be able to see my poll question slide, so they'll see what the answers would be. In my slide, you should be seeing my slide now, and it was what Marcy should have showed you is A, B, C, D, and E. And when you look at what the total live and dead load is, and you add those together, which is the live load would be 40, dead is 10, the correct answer would have been B. So you didn't get to answer that question, but I'll move on to how I can make this a prescriptively designed or a self-designed, self-supporting stairway and not have to just rely on those screws through that headboard if I put some jack studs, so that I've got positive support under that headboard that's going to transfer the load down to the footing. Now, here I show that jack stud is going right down to the concrete on the footing. A lot of contractors don't like to put their wood members on top of concrete for fear of decay and rot when the water settles on there being wicked up into the wood. So in that case, they could use, instead of what I used here as a 4x4 connector at the bottom, they could use a 4x6 connector for the 4x4 and then have that jack stud down on the 1-inch metal connector standoff. And of course, that would be bolted down to the footings using a either a J-bolt cast into that footing or a post-installed fastener like a wedge anchor. So now I've got the headboard fully supported, and I can get on to installing the stringers themselves. There are these new stringer hardware pieces that have been on the market for about, I want to say 4 or 5 years now. The illustration in the DCA 6 stringer attachment looks exactly like what these hangers do. Before these were available, we would use skewable rafter hangers, and some of the manufacturers still let us use those for stair stringers for decks. But those pieces of hardware are mostly only, the ones for rafter hangers are only coated to G90 coatings, so they're not compatible with contact with pressure treated lumber, but these newer pieces of hardware are. And they basically straddle the side of the stringer and strap under the bottom of the stringer. And the next slide will show a close-up of that, one for each of the stringers. There's some minimum requirements that the stringer manufacturers, and they're pretty much uniform on this, have. But unfortunately, the instruction manual does not come with the hardware. Like a lot of hardware that we use, we have to go to either the catalog or the cut sheet for that piece of hardware to find what the requirements are. And it's important to install them properly, otherwise they wouldn't be compliant with their ICC evaluation service report, which is what the code official needs to look at and check and verify to make sure they're installed properly. So the first thing to mention is that whatever framing member these fasteners are these connectors are connected to, have to have a minimum of 3.5 inches of wood extending past the end of the hanger. We can't just trim these flush with the end of that piece of hardware, flush with the end of the stairs. We need to have that that header board extend past it. And the stringers themselves, though the bottom of the stringer does not have to be fully supported by the wood portion of the framing, as you can see here, the hardware does. The hardware has to have a minimum of 4 1/8 inches from the bottom of our framing member to the top of that piece of hardware, which is usually flush with the top of our stringer, to be able to work. And then the bottom part of the stringer, which is unsupported by the framing member or the header board, is supported by the strap of that piece of hardware. Each of these pieces of hardware have a series of holes in them. The holes can be filled with either nails or with the metal connector screws that I'm showing here that I like to use. I've moved away from using, at least in deck hardware connections, I've moved away from using nails and I've moved to using the connector screws. These are proprietary hardware specific, and so you can't mix and match screws between different manufacturers, and they're not just some off the shelf out of my tool belt screw like a drywall screw or a decking screw. These are specifically made to go in the connector hardware, and we have to use the right connector with the right hardware. Some are a little bit larger than other in the screw diameter, so they can't fit in the smaller holes. In any case, all of the holes that are intended to go into the deck frame have to be filled. And then, as you can see here, I'm installing some screws, or these could be nails, into the side of the hanger, into the stair stringer. So there's going to be 2 patches of those, one on the vertical cut and one on the bottom side of the stringer. Those holes would need to be filled, but then remaining are a bunch of holes on the bottom side of the hanger where it goes up against the underside of the stair stringer. Because these pieces of hardware are universal, in other words, they can be installed to be a left side of the stringer or right side of the stringer, those holes in that bottom portion are really the holes for the opposite use, where this bottom sloped angle here would be the vertical portion. So you don't have to fill all of the holes. And in fact, we're better off not filling the holes, because if we put a whole bunch of nails or screws into the narrow section of that stair stringer, there's the risk of splitting it. The manufacturer's instructions for the 2 major manufacturers that make these call for 1 single fastener through one of the holes, and they usually have a circle in that hole with a little bit of a stamped indicator on there, and that's the 1 fastener that goes up into the bottom of the stringer. The rest of those holes can be left blank. The first time I used these, had a code official tell me that I had to fill all the holes, and I had to get the cut sheet so I could show him that indeed I needed to only fill 1 hole, and so he thanked me for that. And ever since then, most officials have become familiar with that, at least in my area. So you can see here on this less than code compliant set of guardrails on this stairway, the problem I want to talk about now is how do you fasten the post at the bottom of the stair to make them stiff enough so that they can actually act as guardrails, because these will be guardrails or the bottom fastening point for handrails, and we want to make sure those are good and stiff. Though these illustrations are from the DCA 6 document, they're not specifically addressing the issue of guardrail post stiffening, but the detail that it shows is how to put the footings at the bottom of the stair stringers. And these details will indeed work to stiffen the post. What we have here, and you can look at the illustration on the left, we have some footings cast beneath the earth surface, down at frost grade or frost level, and then the posts buried in the earth and then extending up alongside the left and the right of the stairway. Now those would, by virtue of being buried in the earth or cast inside the concrete, provide some lateral stability, so we've got a fairly stiff guardrail post connection. So that's one way to do it. Another way to do it, and because I don't like to bury my posts in the concrete or in the dirt, just because even though these are pressure treated and we do have to do field applied treatment to all cuts, so that if I had my 4x4 cut there, I am supposed to field treat the cuts as well as on my stringers. I'm not always confident that that field treatment is going to make that 4x4 fully, and for 50 years from now, rot resistant when it's buried in the earth. So I'm going to try to keep all of my connections above grade, so I can keep an eye on where the decay is occurring and then take remedial actions if necessary. So here what I've done is I've taken a 2x4 and I've bolted that down to my footing. Now this is a footing. I'll talk a bit more about footings in 2 minutes. This is an integrated footing and landing, so it's all out of concrete. And I have 2 J-bolts which were cast into the footing that come up and through that 2x4. So I've connected the 2x4, which is ground contact rated. You don't want to use the above grade rated treated lumber, and there is a mix of that at lumberyards, so we do have to be specific on that and choose the right ground contact lumber. I've screwed the end stringers into the end of the 2x that's fastened to the footing, and then the 2 intermediate stringers, those have been notched around the 2x4 and then toe screwed down to them. So there's a little heel in the back that is butting up to that 2x. So they've got some fastening there, and if somebody wanted, they could put angle brackets. There's no code compliant way of doing this. There's no code or proprietary system or code design for making this attachment. We just do it as best as possible or by an engineered design. So getting on to the post stiffening process, I put a line of blocks that fit behind the post. Now these posts could be either inboard of the exterior stringer, or they could be on the outside of that outside stringer. Both ways would work. Then after I got those blocks in there, I'm going to run a hot dip galvanized 1/2 inch through rod that goes all the way through from the outside stringer, or if the post was on the outside, it'll go through the outside of the post, all the way through all of those stringers to the other side. Now generally I'll have all of my stringers stacked up, and I'll drill all those holes before I actually put this in place so that they're all nice and aligned. And then if needed, I'll use a coupler, a hot dip galvanized coupler, to couple a couple of pieces of threaded rod through if they don't locally stock a 6 foot or an 8 foot long threaded rod, if I need one that long for a wider set of stairs. And then before I tighten up my nuts on the end, I'm going to set another row of blocks flush with the front of my stringers. And then finally I'll crank on those nuts, tighten them up, and it makes for a really stiff post. Pretty much as stiff as the posts that I do as guardrails. And anybody who's familiar with the different magazines that I've written for over the years have seen some of the post to deck frame connections that are both in DCA 6 and have been profiled in different magazine articles. And you've seen how strong those can be. And this is, I've actually assembled this, taken a come along, tied from the top of that post down to a anchor that I have at the ground, and put a scale on there, and have tested this up to about 600 pounds before we get any appreciable deflection on it. So as long as we've anchored those stringers down, it's a pretty robust system. An alternative way of doing that a friend of mine came up with is using a similar block system between the stringers, but then instead of tying a through rod, he uses some of the 1,500-pound rated metal connectors that we typically use for our 1,500-pound lateral load connection, which is profiled both in the code book and in DCA 6. So those brackets would be connected to the block next to the 4x4, and this 4x4 could be either be inside of the stringer frame or outside of the stringer frame, and it would do the same thing. And that just transfer the load all the way through. The important thing there, though, is we would need to have this full assembly of stair stringers attached down to our footing in some fashion. So now I want to move over to the footing. The footings are required to, when the deck itself is attached to the dwelling, then the stair footings have to go down to frost line. And that's what this illustration shows from the DCA 6 in figure 34. It shows how to do that. I just want to zoom in on a couple of the portions of the detail that are important to note because it gets overlooked by contractors who sometimes utilize this detail. First off, those footings have to go at least a frost line or a minimum of 12 inches below the ground level if the frost line is less than 12 inches. So I've just highlighted these portions here to point out we've got a stair stringer, that's the X'd out portion here. We got the 4x4 going down to the footing, and then there's a support block. The DCA 6 shows some 1/2-inch bolts going through the outside stringer, but those are not what we're supporting these stringers by. The stringers are actually supported by these little, call them jack studs or cripple blocks, whatever you want to call them. They're supporting down to the footing. To highlight that, I sort of did an over illustration on the DCA 6 showing those blocks, and also pointing out that any intermediate stringers would need a 4x4 that goes down to that footing down below grade and a jack stud or a block supporting each intermediate stringer. It's not just the outside stringers we need to have supported by a footing. The way I do it, because by the time I dig 3 or 4 footings that are in close nearby proximity, I may as well dig a trench. And in this case, I got a trench that's dug down to my frost line, and then I've dug out for a landing that goes out in front of there. This is the excavation, and this is that same set of stairs with the landing poured out in front of it. Let me show you an illustration that we got from Fine Home Building magazine, just to show that in a little more detail. The footing itself that I would do would be a continuous footing. I usually do a trench pour, though these could be form poured. And then we want to make sure that the full heel cut on the bottom of that stringer is supported by the footing. And then as far as anchorage, I would put some blocking in between there. This illustration doesn't show that, to make sure that we've got some wood that's anchored down. Some contractors will use a manufactured light gauge steel angle bracket. The problem with those is most of those are not rated for use with the fasteners that the contractors use to go down into the concrete, which is usually a Tapcon-like screw. And those are not rated for exterior applications or for use with the hardware. So it would need to have a manufactured hardware that would be compatible with the fasteners that would go into the concrete. Maybe someday the manufacturers come up with hardware specifically for this detail, but as of yet they don't, and that's why I use the 2x that's bolted down to the footing. So the last thing that I want to hit on before we get to the questions and answers is the landings for stairways. There's a code section for that, and this is what contractors usually do. There is a 3-foot portion at the top of all stairways and at the bottom of all stairways. So the imaginary 3-foot in the direction of travel for the full width of the stairs that we can identify at the top of the stairs. That portion of the deck is called the landing, and at the bottom of the stairs where you see grass here, that is called the landing. That would be the same case on this deck, which I replaced. the top part right there, 3 feet in, the width of the stairs is the landing, and 3 feet out here in the dirt and the gravel, which has been scoured away by years of people walking up and down, that is the landing. There's some problems with that. So the code only tells us that the landing has to be the width of the stairway and 3 feet in the direction of travel. The question I want to bring up is, on the earth, where the stairs hit the earth, what are appropriate materials to use down there, and can we put them right on grass or on crushed stone or on loose gravel? The code doesn't give us any direction there. Again, this is just reiterating that 3 feet in direction of travel. So what the code does say in R311.7.7 on stairway walking surfaces, and I'm just clipping a part of that where it says that it shall be sloped not steeper than 1 unit vertical in 48 units horizontal, or 2% slope. So it gives us a slope that we can have as our maximum for our walking surface, which would include the landing. And then on the riser section, R311.7.5.1, we're allowed a maximum deviation between the risers, plus or minus. The maximum deviation would be 3/8 of an inch. So if we go back to these illustrations, this photograph, am I guaranteed on the day that I build this set of stairs, I may have the same riser height as I do with the next riser heights going up this stairway, but am I guaranteed that that riser height is going to be equal for now, a month from now, a year from now, and 2 or 3 years from now? That's where the problem comes in. And I'm just going to go back forward to a slide that shows another ICC publication, which is not the code itself. It's an old out of print, though a new version of it will be coming out this year based on, I think, the 2018 or the 2021 code by Glenn Mathewson. The book, when he wrote it for the 2009 code, was called Deck Construction based on the 2009 International Residential Code. And in here, when he talked about stairs, so this is an ICC publication, there is no material specified in the IRC for stair landings. And this would be specifically related to deck stairs. However, the intent is for a solid, stable material with an identifiable and measurable slope, properly installed concrete, pavers, flagstone, brick, or decking may be all considered suitable landing material or suitable as landings. What it doesn't give us here is a suitable option for just earth, dirt, or grass. The last 2 slides I'll just hit quickly, and then we'll do questions. The first is just other problems that I see in the field a lot. Overcuts on the stringers. We don't want any less than 5 inches of full meat of wood below that stringer cut. And this is from the DCA 6 showing that illustration, and that's how their maximum spans are based. And then finally, on the risers, anytime we have open risers that are above 30 inches above grade, then the same 4-inch diameter sphere we have to prevent from passing through the open risers, just as we do with all guards, because this is essentially a guard for children diving through or falling through. So this set of stairs would not meet the code. So what I'll typically do is just block down open risers so that that space between the top of one tread and the bottom of the riser, that infill, would be less than 4 inches. So now we can open it up to Marcy, Laurie, and questions. Have we got any questions?
All right. Yeah, Mike, hey, this is Laurie. Thanks again. That was great. We had a lot of questions come in, so we'll jump into a few here. We had some questions come in, and if you need the code reference for this, I have it handy. There were some questions on the live loads for decks per the 2018 IRC. Some folks weren't sure, should it be 40 pounds per square foot? Should it be 60 pounds per square foot? Did you have anything you wanted to comment on that? Or, and like I said, I have
Sure.
some IBC references if you need them.
Yeah, so there's live in for the deck portion, all of the tables and everything in the code are based on a maximum live load of 40 pound per square foot, and that's the design load for decks in Chapter 3. And it also includes, or also added to that would be the dead load of the deck, which is assumed to be a 10 pound per square foot load. So when you add those two, it would be a 50 pound per square foot. And that's what all the tables and so forth in the code are based off of, the joist spacing, or joist sizing and spacing, as well as the ledger connections. Now, some jurisdictions around the country have changed the live load requirements to a higher standard. I've heard it as high as 90 in a couple of jurisdictions. And where that has occurred, then the problem is that you can't use any of the prescriptive code tables because they don't go up that high. Now, I understand in the 2021 code, there will be some additional load tables in the code, which will be to higher loads, particularly to deal with snow loads, but those could be substituted for live loads. So do you have anything to add to that?
Yeah, I think also there has been some confusion because the IBC implemented some provisions. I think it was in Chapter 16 of the IBC that decks and balconies require a live load of 1.5 times the area served. So in some IBC designs, if the floor load was 40 pounds per square foot, again, you would need 60 pounds per square foot. But for the IRC, like you said, in Chapter 3, table, let's see, had it and I lost it. I think it was table R301.5 states that decks and balconies for IRC designs are only 40 PSF.
Mm-hmm.
Okay, great. Oh, here's another, this one I'll answer as well. Is the DCA6 available for free download? That is available on AWC's website, awc.org, and you'll see a link for it on the front page. Okay, ledger spacers. We had this question earlier today too. Can you talk about some of the benefits of using spacers on a ledger? I think that was around earlier in the presentation. You had that,
So
that really nice illustration.
That would be the ledger, spacing the ledger off of the wall itself. Yep, let me get back to that slide.
Talk about some of the benefits and you know, some of the differences that you might encounter using that versus not spacing it off the wall.
So the advantage of doing this is we don't have to do any primary cap flashing over the top of the ledger. It was a design that, as I understand it, was commonly used in the Pacific Northwest and in some of the Rocky Mountain states by contractors who build decks regularly. And that's why it was embraced by the IRC when they came up with their ledger fastening table. So this just eliminates the need to do a regular cap flashing. The way that contractors will generally install it is they'll bore the hole for a bolt, and it does have to be a bolted connection, though there are some proprietary screws out there on the market that do have a detail showing the spacer, but by code, for the basic code shows that a 1/2 inch through bolt, not a lag screw, and then using a 1/2 inch stack of washers, and then the contractors will usually put a spludge of sealant on the inner board washer against whatever membrane they have as their flashing. That would usually be a piece of aluminum flashing or a piece of PVC coil stock flashing that goes against the wall just to bridge between the siding above and below the ledger. And then that would be adequate for sealing. That's about all there is to it.
Okay, great. All right, a lot of questions coming in fast and furious here. I think we have time for one or two more.
Well, I can stay all afternoon, but I know you can't.
We know we have our attendees have some limits here. Okay. Is there any special requirement on sealing bolt holes in the space ledger detail here? Do you have to put anything around the hole?
There's no requirement in the code book. What some contractors have told me that have used this for years is they don't put any sealant at all. They've checked and rechecked and continually checked on decks they've built, and they said that under the compression, once you crank those nuts and bolts together, that they're finding that the water, just for the amount of water that hits that area, they're not having problems. But there again, a bead of sealant before the washers get pressed against the wall, that helps. There's nothing in the code book that says it has to be a stack of washers. A few contractors and I myself have used some half-inch thick plastic composite deck fascia board material and cut a slope at the top so it looks like a little A at the top, and use that as our spacers. And that way, it, by virtue of that slope, kind of sheds water too. There's a lot of ways to do it. And it's one of the things if anybody gets to a JLC Live or one of the other presentations I do, we actually do demonstrations and have mock-ups of all this if anybody does want to see it.
All right, great. And just one last quick question. I know you mentioned this briefly, but can you talk about the requirements for using treated lumber? Should we be specifying ground contact? Should we be specifying above ground? I know the AWPA has a few different designations. What would your recommendation be for people to look for?
So there's the long answer and there's a short answer. Let me give you the short answer. If you're gonna have anything touching the ground, you're best off to have ground contact lumber. There was a whole bunch of rigmarole going on with a lot of the lumber when the preservers changed over to the different ACQ, MCQ, MCA, all the other CA, CB treatments that they were using. They were making treated lumber that was just for above ground contact, and they were making most of the framing lumber except for like all of your joist 2x10s, 6s, 12s out of above grade, and most of all of the 4x4s and 6x and 8x, all of post material they were doing to the higher retention levels for ground contact. But what they were finding is a lot of contractors were still putting the regular framing lumber in contact with the earth. So many lumber yards, and all of them around where I live, only stock ground contact lumber. But that's not the case for all of the dimensional lumber. That's not the case nationwide. So any contractor would really need to see what their local lumber yard's stocking. Most lumber yards can get ground contact lumber, and there is a minimum space distance off the ground, and I forgot what it is. Even above ground contact level treated lumber has to be a minimum of so many inches off the ground. And any field cuts, whether it's in ground contact lumber or above ground contact lumber, whether it's southern pine or incised lumber, all have to be field treated with a copper naphthenate or another treatment, and that's per the M4 standard that the code calls out for. So there's a lot behind all of that, and somebody could dive deeper into the details if they want.
Absolutely, yeah. All right, well, I think that's all we've got time for today. Once again, thank you so much, Mike, for sharing your knowledge with us. I want to thank all of our attendees for taking the time to spend with us today. We hope that you will join us again next month. We're going to be doing a presentation on some NDS example problems based off of our new example problem document. And we look forward to seeing you, if not then, hopefully at another event in the future soon. And have a great day, everyone. Sure.
Oh, I just was wondering if this will be posted as a webinar that people can listen to, watch in the future.
Absolutely. Absolutely, and that's
Okay,
a great question to some of our attendees. You will all receive an email when the course goes live on our e-course page, and you'll also be able to find it on our YouTube channel. So stay tuned,
perfect.
keep an eye on your email, and you'll get some information about when it goes live. It should hopefully be in the next week or so.
Great, thanks.
All right, everyone have a great day. Thank you.